2 out of 18 divided by 18 times 100, what do you get?
11.1.
11.11%. What is the percentage of oxygen in water? What is the percentage of oxygen in water? Please, I'm on everyone here. Percentage of oxygen. Yeah. Letitia, what is a no?
Yeah.
Yes. I'm hearing. Yes, Grace, the percentage of oxygen is? 80? 80?
98.88.
98.88.
No, 88.
88.88. Yet here I see 1. I expect to see a 9 somewhere.
Behind the decimal.
88.89, isn't it?
Yeah.
Yes.
So this is the overall percentage of that element. So Grace, have you got the idea?
Yes.
So they might ask you for calculate the percentage composition by mass of oxygen in calcium carbonate. Your mass now to write the full formula of calcium carbonate. Then you can get relative atomic mass or relative molecular mass. And then now the mass of that element X out of the relative molecular mass times 100 gives you the percentage composition. Okay?
Yes.
So you try as much as you can to do these examples, and then there is exercise here for you. Simple terms. That is what we had. So here we looked at the empirical formula and molecular formula. Empirical formula is the simplest formula of a compound which expresses the ratio in which different atoms present in a molecule exist. The simplest formula. They can give you an element in percentage composition. They give you elements in terms of mass, but they want the simplest formula that expresses the element. So this is what we have here. That's the simple steps.
Teacher, I want to talk to Letitia. Letitia? Letitia? Letitia?
Yes, teacher.
Good morning.
Morning, teacher.
Yeah, I've been trying to contact you, I think, all in vain. Have you made payments?
I made payment.
Yeah?
I made payments.
How did you access the lessons?
Normally.
Your subscription expired. How did you access the lessons?
I logged in.
Okay, your subscription expired. I don't know how you got the lesson, and I think you are telling a lie right now. Isn't
Everything
it?
is what?
Isn't it?
I think it's not yet because I logged in.
What we are going to do for Letitia. Letitia, if you find yourself off, you don't have ask why.
Okay. Okay. So these are the steps we're going to use. Calculating. We shall have 1. Write down the symbols of the elements present. Write down the percentage composition either by mass or in terms of percentage. Then find the number of moles. That's what we have been doing. You look at an example like this. Calculate the empirical formula of the compound containing 80% carbon and 20% hydrogen. So when they talk about this, you write what is there. The symbols of the element, we have carbon and hydrogen only. Then carbon is 80%, hydrogen is 20%. Now this is the percentage composition. Step 2 says, step 2, write down the percentage, find the number of moles by dividing the percentage composition by the relative atomic mass. Go to the table and check. So we are going to find the number of moles by dividing this by relative atomic mass. 80, carbon is 12, 20 is hydrogen is 1. When you divide this, you'll be getting the mole number of moles. Then after getting this, we are going to get the mole ratios. Mole ratios are got by find the mole ratio of the element by dividing the moles with the smallest number from here. So Grace, if you divide 80 by 12, what do you get? Hmm? 80 by 12. What do you get? Grace. Yes, Neha.
So you get 6.667.
6.667. Then this by this, you get 20, it remains. So for you to get the mole ratios, you divide by the smallest. 6 and 20, which one is smaller? I think it is 20. So I divide by 6.667, divide by 6.667. So this one and this one gives me 1. This one and this one gives me
2.9998.
2.998. So in simple terms, what they are meaning here is, if the mole ratios is in fractions, and now that fraction is very close to a whole number, you round it off. So here you round it off, which is 3, 1. That's one way. And then if it is very far, you get a number that multiplies it to give us the exact answer and gives us the exact number. So this is, now you copy this, C is 1, H is 3. So that is our empirical formula of that substance. So all kinds of calculations must lead us to all those formulas. So then they tell you that to get the empirical formula, to get the molecular formula, you say empirical formula times N is equal to the molar mass. Now here they are saying B, if the molar mass of the compound is 30 grams, determine it is molecular formula. So the molecular formula is good from this. That empirical formula times N is equal to the molar mass. So empirical formula we have found is CH3 times N, which is equal to the molar mass, which was given 30. Now this molar mass is going to help us to get N. That N is the one that's going to give us the molecular formula. Because molecular formula is that N times the empirical formula. So you get this empirical formula we got here, times the number you get from this. Is going to give us the molecular formula of that substance. So it's like telling us that that N times the empirical formula is going to give us, times the empirical formula is going to give us the molecular formula. Those are the two things we are having there. So if you know the relationship here, look for N if they have given you the molar mass. After getting the N, multiply it by that empirical formula you have got. The formula you get is for the molecular formula. Hope that has helped all people here. Yes.
Yes.
Yes, teacher.
Vanita,
Yes, teacher.
how are you?
I'm good.
Okay, that is good if you are good. So let's go to what brought us here today. The main impact is this: calculating masses from where? Calculating masses from
Equation.
equations. Very good. Ask yourself a question: do you know how to come up with the correct equation of a reaction? If they just read for you any equation at this time, you can write this equation and balance it well. Failure to balance, you will never get the correct answer for this. So moles and mole ratios can be used to calculate the amount of substance reacting and products formed. This requires that a correctly balanced equation is written correctly. These are the procedures you must follow. Correctly balanced equation. That's the first step. Please, if you don't know, those videos are there in the first lesson we have had. Go and look at them, and then you form. Then also, this is called a stoichiometric equation. The stoichiometric equation or stoichiometry is the relationship between reactants and products in a chemical reaction. That's the meaning of that word. So this stoichiometric equation or the equation of reaction will give us the relationship between products and reactants. So always on the left hand side, we have the reactants. Then on the right hand side, we have the products. So it's like A plus B is equal to C plus D. These are the reactants. These are the products. Then steps in writing equation, that one is not steps in doing this work. We have to write number one, write down the balance equation for the reaction. After that, then write down the number of moles of substance that concerns the question. Moles that concern the equation. That concern the question. Then 3. This is 2. This is 1, 2, 3. Then convert the moles in 2 grams. Now, at this point, you should be remembering the relationship between moles and grams. Where does it come from? The relationship they have is 1 mole is equivalent to the relative atomic mass of a given substance. Okay? This relationship, we had it earlier on, isn't it? Yes. Very good. So this words should be ringing in your mind that when I'm calculating this, emphasis should be 1 mole is equivalent to this. When they put particles, you must know the relationship between moles and particles. Okay? So here they are saying, let's look at example 1. Calculate the mass of iron 2 sulfide formed by heating 64 grams of sulfur and excess iron. Now the problem is, what are the reactants? Where is the product? That's example 1. Somebody tell me the reactants. Where are they? Reactants. In this equation, which things reacting to give us what? Where are the reactants? The reactants is which? Where are the reactants? Vanita?
Yes, teacher.
From the equation given here, where are the reactants? Where are the products? You read the question carefully. They are saying, calculate the mass of iron 2 sulfide formed by heating sulfur with excess iron filings. Where are the reactants? Where are the products?
The reactants are sulfur and iron.
Very good. So when sulfur reacts with iron, we get iron 2 sulfide. Iron 2, This is 2, sulfide 2. If you look at those elements there, sulfide has a valence 2 negative, iron is 2 plus. So these ones cross out, leaving us with the correct formula of iron sulfide as FeS. Now, is the equation balanced? This is a solid, this is a solid, this is a solid. If you balance, this is one iron, then one sulfur, meaning our equation is balanced. Okay? So our second step is to write down the number of moles of substance that concerns the question. The one that concerns the question. The rest that don't concern the question, leave them out. Look at the question. What have they given you? They have given you 64 grams of sulfur. So they have given you sulfur, 64 grams, isn't it? And they want the mass of what? Iron sulfide, isn't it?
Yes.
So the two things
Yes.
that concern our question is the sulfur and the iron sulfide. The rest, which is not involved, leave them out, like iron. You leave it out. So we are going to start with writing this. Write the number of moles that concerns the equation. From our equation, you say from the equation, 1 mole of sulfur, 1 mole of sulfur produced 1 mole of what? Iron sulfide, isn't it? From the relationship we had, 1 mole of sulfur in the table is equivalent to what? One mole of sulfur in the table, how many grams does it have? Since they have given us grams here, 64 grams. So we must convert these moles to grams. 1 mole of sulfur is equivalent to, check the table. 1 mole of sulfur, isn't it 32 grams?
32.
Yeah, so these are 32 grams
32 grams.
of sulfur produced. 1 mole of iron sulfide. This one now you get the relative molecular mass, isn't it? Yes? Relative molecular mass.
teacher.
So the relative molecular mass of iron sulfide, they have given you iron as 56 plus sulfur, which is 32. What is the answer?
It's 88.
It is 88 grams. So 1 mole of 32 grams, let me write the equation clearly. 32 grams of sulfur produced 88 grams of iron sulfide. Have you seen how we have shifted from moles to grams now? Yes? We have shifted from the
Yes,
moles
teacher.
from the equation. Now we have gone to grams because of the relationship between the moles and the grams.
Grams.
So what about 1 gram of sulfur? It produced 88 divided by 32 grams of iron sulfide. Then ask yourself, what about 64 grams of sulfur? It produced 88 divided by 32 times 64 grams of iron sulfide. What was that mass? What is the mass there? This is 64.
176
176 grams of iron sulfide
grams.
formed. So 64 grams of sulfur produces 176 grams of iron sulfide. That is the relationship we have. Okay, if you have understood that, then example 2 is somewhere. Example 2. Example 2 is saying Example 2 is saying, what is the mass of magnesium required to form 55 grams of magnesium oxide? What are the reactants?
Magnesium and
Magnesium and oxygen.
oxygen.
Very good. Gas, this is a solid. To form what? Magnesium or oxide, which is a solid.
Oxide.
Very good. Now, is this equation balanced?
No.
No. What should we do to what? To make the equation balanced?
Put a 2 on magnesium oxide and a 2 on magnesium.
On magnesium. Okay. That is our equation. Now, let's look at 2. What is our 2 saying? The 2 was here saying moles that concern the question. The moles that concern the question. Look at the question, read the question carefully. What is the mass of magnesium? Mass of magnesium. So they want magnesium here, and they have given us the mass of magnesium oxide, isn't it? They have given us the mass of magnesium as 55 grams. So we only need magnesium and magnesium oxide. Oxygen, we leave it out, isn't it?
Yes.
Then you copy the moles that concern the equation. You say 2 moles of magnesium produced 2 moles of magnesium oxide. Now, since this is 2 and 2, we can reduce this, isn't it? So these are 2 moles, these are 2 moles. So 1 mole divided by 2, divide by 2. 1 mole of magnesium produced 1 mole of magnesium oxide. That's what we have. Now, 1 mole of magnesium in the table has how many grams? From the table?
24 grams.
24 grams, correct. 24 grams of magnesium produced 1 mole of magnesium oxide. Here we have to bring in the idea of the relative molecular mass. Magnesium is 24 plus oxygen, which is 16. What do you get? One mole of magnesium oxide is 24 plus 16.
We get 40.
40 grams of magnesium oxide. So now what have they given us? They have given us the mass of the oxide, isn't it? 55 grams of the oxide. Now what we do is to write the equation starting with magnesium oxide and this. So you say 40 grams of magnesium oxide were produced by 24 grams of magnesium. Ask yourself a question, what about 1 gram of magnesium oxide were produced or is produced by 24 out of 40 grams of magnesium? What about 55 grams? From the equation, we have 55 grams of magnesium oxide because these are the ones that were produced. Which mass of magnesium gave us 55 is what we are looking for. 55 grams of magnesium oxide were produced by 24 out of 40 times 55 grams of magnesium. What is the answer? There?
The answer is 33
33
grams.
grams of magnesium. Okay. Now, from all those examples we have done, is there anything you have seen that is strange? Is there anything you have seen that is strange? Yes, Melissa. Melissa.
Yes.
Anything that is strange you have seen here?
No.
No. The same old story. Vanita?
No.
No. Cynthia, Uganda. Yes, Cynthia. Francis. Francis. Who is using Francis? Grace.
Yes.
Anything you have seen that is strange?
No.
Okay. So please, you see this exercise down? This one? Please take what's called a snapshot or a photo or what of that work. Take a screenshot of that work, and I expect to see work of some good number of people this time. I want to do one more example, then that number is yours. Those numbers are yours. Okay? Have you got the exercise for today?
Yes, teacher.
Okay, very good. Now, let's go back up here. Let's do number 3, and then we call it a lesson. Number 3. Number 3 is saying calculate the mass of copper formed when 3.2 grams of copper oxide is completely reduced by a metal to hydrogen gas. Give me the reactants, give me the products. Reactants and the products. Very fast. Where are the reactants?
We have copper.
Copper. Read the question very well.
Oxygen.
Calculate the mass of copper formed when 3.2 grams of copper to oxide is completely reduced by the metal by hydrogen gas. Where are the
Okay.
reactants?
Copper. And there is also oxygen
Where?
with the copper.
You people, if you read this question very well, do you think there is a, you know, the reduction reactions and oxidation? We look at all those types of questions. Here we have now, let's take an example here. They want a mass of copper formed. That means there are something that reacted and were reduced to copper. So here we have copper to oxide. So in the reaction, we have copper to oxide, which is a solid, that was reduced by hydrogen gas. So it was reacting with hydrogen gas to give us copper metal plus water. This is what we have here. You read the question carefully, that what is the mass of copper formed? They want the mass of this when 3.2 grams of copper to oxide is completely reduced by hydrogen. That means the two reactants were copper and hydrogen gas. So when they reacted, copper to oxide was reduced to copper metal, and the hydrogen became oxidized to water. Addition of oxygen to a substance. That's oxidation. So we have a solid, we have a liquid. When you try to balance it up, you have 2 hydrogens, 2 oxygen, 1 copper, 1. So is the equation balanced? So the equation is fully balanced. Now, look at this, that they have given you the mass of copper to oxide. You have copper oxide, 3.2 grams. And they have given you, they want you to find the mass of copper here. So remove this, write what concerns the equation. 1 mole of copper oxide produced produced 1 mole of copper. Now, from here, 1 mole of copper oxide, you must know this is a compound, you get its relative atomic mass, which is going to be 64 plus 16. What is here? It is 80 what? Is it 80 or 88? Copper is 64 plus oxygen, which is 16. That's the relative atomic mass. They say 1 mole. 1 mole of this is equivalent to relative molecular mass. So the relative molecular mass of this is what? 88 or 80?
80.
80. So here you say 80 grams of copper oxide produced 1 mole of copper. 1 mole of copper is 64 grams, isn't it? Of copper. Now they have given you 3.2. What about 1 gram of copper oxide? It produced 64 out of 80 grams of copper. What about 3.2 grams of this? Is 64 divided by 80 times 32. 3.2 grams. What is the answer? What is the answer there? Lynette, what is the answer? Lynette has escaped. What is the answer?
It's 2.56.
2.56 grams of copper were formed. Now, look at the question to how many grams of water were produced. Look at the copper oxide and water. The rest don't mind about them. How many grams of hydrogen were used in the experiment? Look at the copper oxide and hydrogen. That is all. Use more ratios and compare. That is the answer there. So I expect to see work of 11 people in the course of the week, and this is what we are going to do. Since answers are there, I will mark basing on the answer, and we call it a day. Is that okay?
Yes.
So somebody had a burning question before I go away. Someone has a burning question? Yes? So if there is none, today people have enjoyed the lesson, so I expect to see serious work of this. Thank you for attending, and I wish you the best of the day. Senior threes, we might have a lesson at 2, so you better be prepared. When you see the link, you join. Okay? Is that okay?
Yes.
Lynette, you are on and off. Lynette, you fail to submit the answers. I'll start chasing people one by one. Okay, thank you for attending.